Welcome to the Mount Druitt STEM Club. And this week we continue with topic 3. Last week we covered time, and this week we're going to cover distance. So we'll be looking at distance measurement with microbit. And I'm using a mind map here to explore the topic, and I'll start off with what our objectives are. We'll have a look at the devices we're using, and there will be 2 sets of projects, the simple ones and the more advanced ones. Most of the advanced ones you can do yourself with some guidance. We can complete the session with a review, and I'll give you some references so that you can follow up. So one of the objectives that I've got is to discover what a distance sensor is. And one of the ones I'm using is an ultrasonic transducer. And it also goes by the name of ultrasonic range finder or ultrasonic distance sensor. So how does it work? We'll also be looking at how to use the Grove Ultrasonic Range Finder. And we'll have a look at what the limitations are and are there alternatives available. So what could you do with a sensor like this on your microbit project? So the projects we'll look at this week include a measuring distance and a COVID-19 social distance measurement or trainer. And later you can consider other projects, a theremin musical instrument, and also to have a look at which distance measurement sensor performs the best. And we're also going to learn a little bit more about make code and do a couple of coding exercises. We'll be looking at extensions to make code, and there are 2 of these we'll use. One of them is to support the neopixel LED strip, and the other one covers 2 of the Grove modules we'll use, a 4-digit display and a ultrasonic sensor. We'll also be using the music blocks, partitioning our program with functions, using logic blocks, and we'll introduce for the first time the for loop. So the devices, well, you've already seen how to use the microbit and bitmaker, and we've seen how we can connect sensors and actuators to bitmaker with the Grove cables. So we'll be extending that this week. So the sensor we'll be using is an ultrasonic sensor, and you can buy versions of these for about $4 on eBay. We'll be using the Grove ultrasonic distance sensor, and that comes with your Bit Gadget kit. So open up your Bit Gadget kit and see if you can find it, and get ready to plug it into the bitmaker board. There's another sensor that has been delivered this week, and we'll use that next week when we look at a new topic on weather, and that's the Grove BME 280, which is able to measure temperature, humidity, and pressure. And we can actually use that in conjunction with the Grove ultrasonic sensor to get more accurate readings. That'll be a more advanced project that you can follow up. Now, some of the other distance sensors include infrared, or the laser light Lidar. And there's also a Grove time of flight. The Lidar sensors, most of the cheaper ones will only measure up to about 3 meters, but you can get Lidars which will go much beyond that. And you can buy them for $12 for 12 meters. So what's a Lidar? And it's becoming quite popular now when we're considering the autonomous cars, self-driving cars, and it's one of the sensors. So if you look at this vehicle, it's got a Lidar on top, and it rotates and is able to detect how far away it is from obstacles like other cars or other buildings, for example, or people. So Lidar stands for light detection and ranging, and it's a remote sensing method to measure distance. It uses light in the form of pulse lasers to measure range. And here's an example of a Lidar which was used recently on the Ingenuity helicopter, which accompanied the rover on Mars. And it's now done about 22 successful flights. And a Lidar proved to be very useful in helping it with the landing and for the navigation on Mars. So with the actuators, we'll be using a 4-digit display. It's a Grove display, and you connect it with the Grove cable to bitmaker. And we'll also be using the Grove neopixel strip. And that's a RGB, that stands for red, green, blue. So it's an RGB LED strip. And if we have time, perhaps later on, you could use the Grove speakers instead of the speaker on board the bitmaker board. So just a little bit more about the Grove 4-digit display. You can see it on the photo here, and it would be great to use this for a clock, so you could have hours and minutes. We'll be using it to show distance. And the RGB LED strips come in 2 varieties. There's the linear array, and there's the circular array. We'll be using the circular array on our projects today. So there's quite a few simple projects you can tackle. We'll be looking at 2 of these. One is the distance measurement, and there'll be no compensation here, so it won't be so accurate. But you can compensate that, perhaps when you get your weather sensor, you can compensate for the temperature and humidity. The other project is keep your distance. And in COVID-19, there has been a requirement, and it's still a good idea to keep your social distance. And the project that we've got in mind will give you a warning if someone is getting too close to you. The more advanced projects are listed here, and the theremin is one of the first electronic musical instruments. And you use your hands to change the notes and change the volume. So that's one of the options you can follow up. Another project could be to use more than one sonar or ultrasonic rangefinder. And on a theremin, you could use one sensor to sense with your right hand for the music, the volume of the music, and the left hand could be used to change the notes or select the notes. Some of the other projects are microbit location stamping. So if your microbit is moving around, you could use a distance or a location sensor to track where it is. And perhaps we could use this on our koala project. Another project could be that you imitate and simulate the behavior of a bat. And the bat uses a similar sensor to our ultrasonic sensor. And if you get too close, we could get our bat to fly away. So how does a ultrasonic transducer work? Well, on the device that you've got, it's similar to this one, but yours has a Grove connection on it. It has both a transmitter and a receiver. And the signal that's sent out is an ultrasonic sound signal. And if there's an object in the way, it will echo back. And what we're measuring is how long it takes to get that echo back. So if we know the speed of sound, we can then calculate how far away the object is from our sensor. And the reflected wave is picked up by the receiver. So knowing the speed of sound, we can measure how long it takes to get that reflected wave back. And from that, we have a very simple formula that enables us to calculate how far away that object is. And the Grove ultrasonic sensor is the same. It's got a T for transmit and an R for receive. And you can see the Grove connection. And we've got the ground, the signal. The middle one's not connected, but the one on the end, which is connected to the yellow Grove wire, that's where the signal is sent out from the transmitter, and it waits for the received signal to return. So here's the software. Not that complicated. It only has 2 blocks, one for setting up the 4-digit display, and the other one grabs the received signal, turns it into a distance, and shows that on both the Grove 4-digit display, and it also shows it on the microbit LED array. So let's have a go and see how it works. So you start off with the make code. So you've gone into Grove to Chrome, and we start off with 2 blocks, the on start and forever. And what we're going to do here is add an extension. So go to the extensions, and when you get to the extensions, we want to add the Grove extension. So just type in Grove, and you'll then see that the Grove block has been added to our toolkit in the middle. So you can explore some of those now and see what they look like. The first one you'll notice is support for the 4-digit display, and we'll be using a couple of those on our project. So if you want to see this in detail, you can see the YouTube video on that, and I'll be posting that in the chat area. So let's have a look at it in detail. And after we've done that, download it into your microbit and see how accurate it is. Perhaps if you've got a ruler there, you could check to see how far away your hand is and on the scale, and measure the accuracy. So here are some references that relate to improving that accuracy if you want to go further. Okay, so if you wanted to go further, the sound is influenced, the speed of sound is influenced by both the temperature and humidity. And you can see that, say at 20 degrees with a humidity of 50%, the sound is 344 centimeters a second. And you can see that, oh, that's meters per second. And you can see how that varies. So the speed of sound will increase with increasing temperature. And if we reduce the humidity, the speed of sound will go down slightly. And what we do, we can use our BME 280 to measure both temperature and humidity, and we can use that to adjust and get a much more accurate reading. So let's have a look at our second project. And this is a social distance trainer. And to put the hardware together, we start off with the microbit. We put that on the bitmaker, and we add our first sensor, which is the Grove Ultrasonics Range Finder. And that goes to port 16. So have a look under the column of button A, and you will see that the lower one there is P16, and that's the one that we use for both connecting the Grove cable to bitmaker, and we also use that reference in our software. And for actuators, on P2, we use the Grove neopixel strip, and that goes on column B on the bottom. And also on column A, under port 8, we connect via Grove cable the Grove 4-digit display. And of course, we need a personal computer, and that's where we'll do our coding and download the program via the USB cable. There is an additional USB connector on the back of bitmaker, and if you're not getting enough power to the microbit and bitmaker, you can add a second USB cable to give you some extra power and then switch on. There's a switch at the back of bitmaker, and you can switch that on. Let's have a look at the code. So there's the total code, and we're going to do a walkthrough of it. So on the upper left-hand area, we've got the block on start. We've got the forever, and under that, we've got a function, which is get distance. And we've got another function, notify the results on the right. Let's have a look at each of these in detail. So here's the on start, and we use a block show string, and this is an abbreviated name for the program, Social Distance Trainer version 4M. And the first thing we do under that is to set up the Grove 4-digit display, and we set it up at the ports P8 and P14, and you've got to put them in that order. And the first thing we do is just clear the display in case it's been used by a previous program. Next thing we do, we set up the Grove neopixel strip, and I've called it LED strip. And it's been connected to port 2, and it has 30 LEDs, and we're ready to go with that. We also set up the minimum social distance, and normally you would set that up for, say, 1.5 meters or 150 centimeters, but for convenience, just for testing, here I've just set it at 40 centimeters. And at the start, I'm playing a melody, and I'm showing blue on the LED strip. Then I'm waiting a second before I proceed. The forever loop is quite simple. It just calls two other functions. One is the get distance, and the other one is notify the results. So the get distance one grabs the measurement of distance from the ultrasonic sensor block. And remember to select the centimeters and not the inches block. And that's been set up at port 16. And that measurement goes into a variable that we've set up called distance centimeters. And we put that onto our 4-digit display. And then we pause a little bit before we repeat that. In notify the results, I've got two portions here. The upper one is checking to see if our distance is less than the minimal social distance. And I've set that at 40 centimeters. So if it is less than, we're too close, and we show an unhappy face on our microbit LED array. We also show on the LED array the distance that was measured, and we play a tone, 2 tones, to give some audible warning that we're too close to the other person. And to give it further emphasis, we show a red color on our LED strip. On the bottom, we've okay, and we're beyond the minimal social distance. And here, all we do is just set a green. There's no music being played, and that's all we do. So now you can download it to your microbit, save it on a USB drive, and test it. And if you want to see the construction of the code in MakeCode, see it on YouTube at that location. So to go further with this, you could change the number of LED modules on your neopixel strip. So if you're measuring at the right, you'll have more green LEDs displayed. So this is a project you can do yourself. And other possible projects that we've mentioned in music, we've got the theremin. We could move the bat wings. Also, as shown on this photo, I've constructed robots that use the ultrasonic sensor to avoid obstacles, and the robots can avoid collisions. You could use it to measure the dimensions of a truck. So it can be used for all sorts of things. And I've listed some of the other projects that for both distance and for location. So this is the theremin being set up and checking where the musical notes are. So we've set up musical notes on a piece of paper for C, D, and E, and we're just checking those out here with the microbit. And that's the objective. And this is the simple design. The bat project allows you to move the bat wings if you're too close to the ultrasonic sensor. So they're projects that you can do on your own. So in review today, how did you go? You've learnt how to measure distance with an ultrasonic transducer. We've seen some of the limitations of that sensor, not only in range, but also in the variations with both temperature and humidity. We've also discovered some of the alternative distance sensors that are available, and it's your choice. You can then look at what project you'd like to do and construct and select a sensor which is suitable for you. And a good one to try would be the theremin musical instrument. And we've used some extra blocks on our make code. We've used the music block, the function, the logic blocks, and the extensions for the Grove and the neopixel array. And here are some of the references that if you want to follow up. You've got plenty on make code and microbit, and you can follow some of the suggestions that are made there. Okay, so that's it for this week, and come and join us next week. Bye from now.